Welcome everyone to the Nebraska Wind and Solar Conference Renewable Energy Series featuring the Southwest Power Pool. A couple of housekeeping items to go over. First, your audio will be muted during this session. If you hover your mouse over the bottom of your screen, you'll see a toolbar pop up. On this toolbar is the Q&A where you can submit questions for the moderator and speaker to review at the end of the presentation. There's also a hands up feature. If you're having technical issues, you can click on that and we'll do our best to help you out. With that, I'm going to turn over our session to the moderator today, Courtney Kennedy, Manager of the Alternative Energy Program at Omaha Public Power District. Courtney?
Thank you. Good afternoon. As Anita said, I'm Courtney Kennedy with OPPD, and definitely excited to be here today and that you've joined us for this webinar. Given the changes last year, Nebraska Wind and Solar Conference is trying to bring a variety of topics to you. And so today we're excited to bring you the Southwest Power Pool. Before I turn it over to our speaker, as Anita just mentioned, we'll be using the Q&A box at the bottom of your screen, and I'll try to get to as many questions to answer those as possible at the end of the presentation. So without further ado, I'd like to introduce our speaker for today, Casey Cathey. Casey is a 19-year veteran of the power industry and a subject matter expert for energy markets, grid operations, and transmission planning. He was a leader in the integrated marketplace Day 2 energy market implementation, from cost-benefit study through go live and support and maintenance after go live. He has also operated and supported the balancing authority, reliability coordination, tariff and scheduling, and transmission operation functions. Casey and his team are currently responsible for transmission planning, modeling, reliability assurance, and resource adequacy. He holds a Bachelor of Science in Electrical Engineering from LSU, has held a professional engineering license for 14 years, and has an MBA from the University of Arkansas at Little Rock. Without further ado, I'll turn it over to Casey.
Thank you, Courtney. Let me share my screen. All right, to do a sound check, Courtney, can you hear me?
Good.
Okay. All right, and my screen's good? Okay. All right, well, this is definitely different than the last time I gave a presentation to Nebraska Wind and Solar Conference. I would prefer the face-to-face approach, but it is what it is. So today we have an hour with questions and answers, so kind of have a lot of content to cover. We tried to distill down some of the, I think, more impactful, valuable items that we believe the participants of the conference would be interested in. So I'll cover basic overview of where we're at with the changing fuel mix that we have, some Nebraska specific data, some observations. I do believe the GIQ is kind of a hot topic with SPP and the membership. And then what does the future hold? I think that's an interesting topic on where we're going from here. And then if we have some time, I would like to give an update on what we're calling script. So we'll go ahead and get started. I know you guys have seen this map before, but maybe you haven't. I do want to just start there just to give a visual for those that aren't directly involved with SPP's RTO business. It does give a nice visual on the overall footprint for what we're covering as SPP full membership. Now, we do have contract services for now the Western Energy Imbalance Market in the West, as well as reliability coordination services in the West. But what's highlighted in red is the full membership as of today. So the last time I gave a presentation at the Nebraska Wind and Solar Conference, I think was about 15, 16 months ago, and it seems like a lifetime. And I think it was November 2019, I believe. And during that time, we were still seeing a trend upward of wind and a trend downward of coal, and gas kind of hovered around the same. Well, we're still seeing that trend, and I am here to say that we did, I guess, break a record in the 2020 timeframe that wind was the top resource for SPP as a footprint. Coal, it barely exceeded coal for the overall gigawatt hours that we tracked serving the load. So that was a pretty interesting record to see, and you can see it in the graph. So that's updated numbers, and it exceeded the coal. Can you guys see my mouse as well? That's Courtney.
Yeah, I thought yep, there it is.
Okay, all right. I'll just use it as a pointer if that's okay. Another observation, which was interesting, is since the last Wind and Solar Conference, I believe we had roughly 20, just a little over 20 gigs installed for the SPP region for wind. And since then, we've actually got 28,000 gigs installed. So we've installed, I think I did the math the other day in preparation for this webinar, that we installed 6,400 megawatts of wind in addition in that 15 months time frame. That's pretty impressive considering the pandemic and everything that's going on in the world. So now we're at 28,000, right about 28,000 installed today, just over 13,000 individual turbines. And we still have 11,600 unbuilt with signed generator interconnects across. That includes Nebraska across SPP's footprint, and another 53 gigs in different stages of study and development. So I wanted to talk a little bit about, some of the stats that we've seen. As you can see, all the stat dates on this slide are past the last conference. So we've actually exceeded our maximum wind output just the other day at 20,108 megawatts. So that's total output for wind for the region. Our minimum wind output has been updated to 252, and I did want to speak to that a little bit. That was in January. Our max wind penetration, we're consistently predicting around 75 to 80% wind serving load. I do believe that we'll break this record come April when we have a large amount of fossil fuel generation on outage and our load is lower. We will probably exceed that 73.2%. Another highlight is our last stat for max 1 hour ramp is 3,700 megawatts. The thing about wind is it's not transient issue. What we've seen is kind of a slow burn, and we've seen it over the last 5 or 6 years. Indicated at the last conference, it's still a problem area for SPP in managing wind. From my experience, all fuel sources have pros and cons. They all have different attributes, and wind is no different. This is a particular day last year in February where we had a large amount of wind serving load for the region in one day, and then the very next day, wind dropped in 21 hours time frame. Visual perspective, this is something we need to predict and we need to get a hold of and basically replace. For my career and really look at the next 10 to 15 years, I really see us in a large transition. Obviously, the energy industry is very active. It seems like every single day something else is new and changing. And right now, what's really given us the ability to manage the amount of wind is the amount of gas that we have. We don't have much solar. We have one battery that's wholesale in our market. We're in this really transitionary phase to where we're utilizing a large amount of gas to be able to bounce against these wind swings. And that's very important that we have that gas at least until something else can replace it, such as batteries or solar. So this is an example of kind of the 1 hour wind drop that what we witnessed. And what I wanted to highlight is the manual and quick start. So we're still leveraging a large amount of gas when these wind drops occur. And this is kind of an area from a reliability coordination perspective and a capacity management perspective that we really need to keep an eye on as we transition the regional fuel mix. As you can see in the pink, those are all quick starts or manual starts that the operators had to make. They were not optimized in the day-ahead market, and they were not necessarily prepared for it. And so when the operators see these wind drops, they have to react and they have to put things online. And so going forward, as we see more coal retire, more gas even retire, what will replace this pink is kind of the big ticket question. Is it a combination of solar and batteries? Is it something else? And so that is definitely something that SPP is spending a lot of time trying to develop policies and processes and tools to be able to understand what is going to replace when the wind isn't there. I thought this was pretty timely and interesting. So icing is an issue, and this was actually last night. And so I thought that everyone could probably relate to the ice storm, and we are still seeing impacts in real time. As of this morning, I've got some updates from our operations and uncertainty response team that we have on site to be able to look at, kind of question the unpredictable and try to predict what we don't know. And so this is a screenshot of what we saw last night as far as icing and the impacts of the wind farms. And all of these light purple and dark purple areas, those are wind farms that have icing issues and are impacted. Their output is impacted by icing. And so this is yet another challenge we have to overcome, is when this happens, it may not be for a 1 hour or a 21-hour period. It may be, in the case of this week, a 3 or 4 day issue, such that these wind farms are not necessarily outputting to some decent extent to be able to be replacing their power that's lost. And so we have to come up with other issues. And today we're doing it with gas. This is another low wind occurrence that happened. And this is an area, this happened Monday. So this is pretty timely as well. I took this screenshot from SPP's website, and it was less than 1% capacity factor for wind. And so something that we're still working through with all of these is trying to figure out, wind is a good resource, but we're trying to figure out how best to quantify the amount of capacity we can rely on with wind. We've developed something called effective load carrying capability policy. We're doing the same thing for solar, and we're doing the same thing for storage or electric storage resources. We're also working on a policy for hybrid resources. Mostly these hybrid resources are batteries coupled with solar or batteries coupled with wind. And what we're trying to do is, there's value to these resources. If you install a 200 megawatt wind farm, you need to have some level of capacity to count on for your load responsible entity. And what we're seeing is there's still times, this is with 28,000 megawatts. I mean, if you look at roughly where the installed capacity is, with 28,000 megawatts, there are time frames where we're nowhere close to 28,000 megawatts. And so solar can have a complementary effect to the wind. Batteries can have a complementary effect, but we have an active priority to ensure that the capacity and the planning reserve margins that we set at SPP are appropriate for the region, such that we're not running off a cliff. We need to make sure that we have the appropriate mix of resources to be able to meet the load. So from a Nebraska perspective, this is Nebraska, and this was as of February 4th this year. You have wind and coal, so coal and wind, gas is the yellow. It kind of gives you an idea relative to other states within SPP what the overall mix is. Nebraska, just on observation, has a decent mix of different fuel types and fuel sources. So that's pretty good. Registered capacity, since the last conference, I pulled the numbers, and it looks like Nebraska installed 3 separate large since the last conference, about 800 megawatts in addition to what was reported last conference. So you guys are roughly hanging right under 3 gigs of installed capacity for the footprint, or for the state. I like this visual because it gives you an idea of what we're dealing with holistically and across time. So as we're installing wind, certainly the overall in aggregate wind capacity factor does increase. And so since the last conference, again, we've increased that line, but there are these transient periods where wind is low, and we have to figure out what to do about those. This is a nice relative graph to show what other states are doing. And I think the observation here is that all states are installing wind consistently. So out of that 6,400 megawatts that I reported, every single state had some level to that. We don't have a lot of load in Iowa, and so Iowa wind is mostly in MISO, and I can tell you that line is more of an increase. So this is just from SPP's perspective. It's not total state, except for some of the states that are wholly within SPP. Okay, moving right along, just go to the state of the queue. So this is a hot topic at SPP. It has been for a number of years. We have a large queue. This is a visual of the wind resources, and it's all over the place. So you can see there's not really a cluster of wind resources attempting to get through the generation interconnection queue. It's kind of all over SPP's footprint. And certainly Nebraska has their fair share of additional wind farms looking to interconnect. This is, well, no, I'm sorry. This was SPP's registered. So these are all the installed wins. I was read it wrong. This is the solar registered. So we have roughly just shy of 300 megawatts of solar. This is still an area where is, I think, our next frontier, especially in operations and markets. We have roughly 20 gigs of solar in our queue. I have some stats on the next slide, but we've yet to see an inrush of installs. And so once that occurs, I think that's going to shed light on a lot of the issues that we may have seen in operations and markets, and really try to understand better solar forecasting, better policy to be able to mitigate or operate solar in an effective manner coupled with wind, trying to meet what's called net load. So here's the queue. So I said 20 gigs. It's actually 35.7 gigs, 40 gigs of wind. This is the latest numbers as of January 13th. One observation I wanted to mention about the GIQ is we have 9 gigs, roughly 9 gigs of of storage in our queue. And that storage is all the same technology. It's all lithium ion technology. 2/3 of that storage is coupled to some extent with wind, solar, or both at the same point of interconnection. So that's interesting to me because you've probably read that storage is coming down in cost across the board. EV is a big thing. Now, when you look at wholesale storage, there's still investment tax credits that can have a large impact on business decisions to install solar coupled with storage. But what was interesting to me is really the inverse of this stat. 1/3 of storage in the queue is isolated without a different fuel source. So there's obviously a business case to be made within SPP's footprint to install storage for various reasons that are not coupled with solar for their investment tax credits, for instance. So that's interesting. It's as battery storage or storage technology gets cheaper or more cost effective, I think that number is definitely going to grow. Okay, so this is the slide I was looking for. This is a visual on the queue. And so this is up to date as of January 27th. And what the observation here is it's still across the board. And I think that's good. That's definitely good from a regional diverse perspective, weather-based perspective. The map I showed about icing, well, that, you know, there's a line in icing. So really the southern resources can be able to help the northern resources in those types of situations, depending on the situation of the load. Same thing in summer. Usually the load is higher in the south. And so the northern resources can help the south. So being regionally diverse within SPP's Consolidated Balancing Authority is excellent. So let's talk about the queue a little bit. I think I'm doing decent on time. So we're 4 years in a backlog. And at this point, given our current processes, we will never get out. We will not be able to process that large amount of queue requests ever. And so we have to do something. And you know, first you have to look at why we're in a backlog. One is the queue was never designed to have wholesale regional fuel mix changes. It was designed for, in my mind, incremental gas or incremental resource over time to serve load increases. It was never designed for swapping out large amounts of renewables or fossil fuels for renewables. But here we are. And so we have more generation in our queue than we have total load at peak. And so we're trying to figure that out. Some of the problems that we've seen are speculators that are wind developers or solar developers that may utilize the queue to determine what the cost effectiveness of the transmission upgrades necessary to interconnect. And so that's one area that we've seen as a kind of a barrier for increasing or clogging up the backlog or the queue. Uncertainty of what actually comes out of the studies is a problem. There's kind of a low financial commitment based on our 3-phase study that could lead to, you know, more speculative customers. And there's a high number of models. Now, this is we definitely have a tangible aspect and control over. We have over 404 models for a particular study. And you didn't hear me wrong. I validated all of the different models that we use for short circuit, for transient, for power flow, for voltage stability. And so they're all for a purpose. We have to figure out, when we try to interconnect a resource, we have to figure out what the impacts are for these resources, and they have to pay a certain amount of transmission upgrades to be able to effectively connect reliably. And but we have identified that there are ways to still get there without so many models, without over-engineering the process. So that is something that we're trying to balance and really cut scope. It comes down to cutting scope, but we need to be careful and ensure that we're not cutting scope such that we're putting the grid at risk, and making sure that we're not catching on the back end where we allow a resource to connect and then we see issues and we have to scramble to fix it on the back end. So the goal right now, and this is a corporate priority for SPP, is to get out of the backlog. There are a number of reasons for that, and I think that that's pretty curious. It's not just, do we need to just process all these generators? Not all these generators have an obligation to serve load, but there's renewable portfolio standards, there's state standards, there's overall desire for load growth and customer growth, and some of those require sustainability and certain renewable goals. And so you kind of have to look at the GIQ as a holistic view of how we increase load additions at SPP, how, for NPPD, OPPD, LES, how they assess and attract additional load to their footprint. And when they do that, they need some assurance that there's deliverability from maybe renewables. And so part of getting out of the backlog is not just looking at the queue in isolation, it's looking at the overall business strategy of various members, various business goals at SPP, and understanding we have an open access transmission system. SPP, we have an ownership to try to fix this and try to get out of this backlog, allow developers to do what they want to do, and allow our load to be reliable in the process, and maybe get some benefit out of these cheaper incremental fuel resources. Okay, so just real quick, because this can take probably the rest of the hour talking about what we're doing. So this is actively being pursued at what we call a Generation Interconnection User Forum, and we're trying to develop an overall approach that's stakeholder driven and making sure that our stakeholders are okay with the changes that we develop. This is a specific targeted plan to mitigate the backlog. I'm just going to talk briefly over it because we just don't have enough time. But some of the things we'd like to do is expand. Right now it's queue-based, almost like a line at the grocery store. And so if someone gets out of the line, that maybe this is a bad analogy, but if someone gets out of the line, you have to restudy that who all is in that particular cluster. And so to the extent that we can make multiple exit paths or exit ramps for certain participants without disrupting an entire cluster of other customers in the queue, then that makes it more effective and efficient. We kind of want to add some quality to the overall pecking order of priority. That's another thing. So how can we ensure readiness based on all queue customers, or all GI customers are not created equal in their status and time frame within the queue process itself. And so how can we extract that data to understand where people are at in terms of their overall readiness and development aspects, and how can we shuffle the queue to be able to process things a little bit more effectively to get to the end goal? Can we increase financial commitment? I mentioned that before. That is a delicate subject because you want to make sure that you're still having the spirit of an open access transmission system, and you don't want to cost prohibit real customers that may actually have the means to build by putting an artificial barrier on the front end. So we have to make sure that it's, if we do increase, that it's very well thought through what those increases may be, and that we're really getting to the right goal. And then reduce the length of time. I think members and SPP staff have different interpretations internally and externally on what that might look like. Can we get our process down to a year. That's really what the ultimate goal is. I don't know. And so, but it's going to take some team of policy changes. We're going to have to cut some scope, but we're going to have to make sure that the scope that remains is really indeed robust enough to be able to address the purpose of the GIQ and really ensure that whatever we get through and has a GIA, we've identified the appropriate upgrades for them to interconnect. I think I need to speed up a little bit because I do want to spend some time on Q&A with you. But this is a visual. So if we don't do anything and this assumes no restudies, this is the queue where we're at. And just to highlight, if we're in 2021 and what we're working on is 2017, this just kind of gives you a cue that fast forward 3 years from now, maybe it's me or maybe it's another SPP staff member talking to the Wind and Solar Conference. If we don't do anything, we'll be studying DISIS 2020 in 2024. And so that's kind of proving out that we're not pulling out of the queue. We'll still process. People will still be able to implement and integrate additional resources, but we're studying things that are frankly older in the queue. This kind of gives you a visual. Again, this is not vetted fully through the membership, but it gives you kind of a visual on if we implement the changes that we're considering over the next 6 months with our membership. We will catch up by 2024. So I apologize. This is the visual that was given to me. I kind of want it to look like the previous slide. And so the idea is just to visualize that it will take, even with policy changes and everything that I mentioned, it'll still take about 3 years to get caught up such that we're through all of these DISIS studies. And we're at 2024, we're actually studying 2024 Q. Okay. So this is pretty fun for me. This is part of my current responsibility is what's called the integrated transmission plan. And what I think is fun is trying to figure out what the future holds. And it's always been pretty challenging for planners to be able to plan the system reliably 20 years out in the future. I mean, who knows what's going to happen next week with the stock market. I mean, 20 years is a long time, but you can't build transmission overnight. In fact, based on the statistics I've seen, it takes at least 6 years to build large transmission lines. If you all in from the point that we say this is the transmission line to the point that it's actually energized. When you talk about permitting, you talk about building, you talk about all the approval processes, it takes about 6 years, and it can take even longer than that. Depending on restudies or reevaluations or maybe issues within certain approval processes. So 6 to 8.5 years. So we have to be able to predict the future and try to assure that the transmission that we're building is appropriate and it's beneficial, because transmission is not cheap. But if we build the right transmission, it's very cheap from a benefit to cost ratio perspective. And so I just wanted to talk a little bit about, since it's the Wind and Solar Conference, just some of the things that we're looking at. The way we do an annual ITP, and that is reliability and economic transmission planning blended together. So our annual ITP was approved, our scope was approved 2022 this past January at our MOPSI, our full represented MOPSI. And so the way you read these are, you have future one and future two, you add these numbers to the year that we're studying. So 2022 is the year that our study ends. We actually started the study last summer, but in October of next year, we will have a final portfolio that we present to the full membership of transmission we need to build. And we do this every October. And so the way you look at this is you take this number up here and you add it to the 2022. So just to highlight some things, we look at two different futures. You look at 5 and 10 years out, as well as 2. And for instance, you look at future 2 and you say 10 years plus 2022. So the year 2032, what does the system look like? And so we use all of these member and SPP vetted and also the market monitoring unit vetted assumptions, such as coal age-based 52 years. We retire those resources unless there's a waiver request through the membership. Current industry forecasts, we use a gas forecast vendor to determine what does the gas price look like 10 years from now, and so, or 10 years from 2022. So the thing I wanted to highlight is just some of the projections that we're starting to see. It's carrying forward. Really, the theme here is that it's carrying forward from what we've seen in the last 7-8 years. And some of the solar and wind numbers I wanted to highlight. So both our futures, you have kind of a reference case for future one and a more emerging technologies case for future two. And what we attempt to do is look at the state of the system for both futures and develop a portfolio that meets both futures at the same time. And so that's a pretty interesting challenge for transmission planners at SPP. But just to take an example, you look at solar, 15 gigs of solar in 2032. So in this particular state, we're predicting 15 of that 35 gigs of GIQ is going to be installed by 2032 in this particular future. And the whole purpose of this is to be able to blend economics and reliability such that we have a good transmission grid that's reliable, that kind of meets all of the needs of members. Something else to note is we have a 20-year, we do this every 5 years, and it just so happens with the change in administration, it was kind of interesting. This was already being contemplated prior to the results of the presidency, but I did want to just highlight it. So this was also approved in January. This is 20 years plus the 2022. So the same thing, you read this, you say 20 plus 2022. So the year studied is 2042. And so one thing to just note is future 3. So this was a more aggressive accelerated decarbonization future. We do not issue notice to construct out of this study. So no money is invested in this study other than the cost it takes to actually run the study. But there's a lot of value here because what it does is it helps with different bookends between future 1 and future 3 on what the grid might look like. We actually develop solutions for the needs that we identify in these particular futures. And why that's important is it helps give us, not just SPP staff, but also the transmission owners and transmission operators, planning coordinators, transmission planners at SPP's footprint, some guidance and guidelines on what the grid might look like given the more accelerated decarbonization. I mean, if you look at these numbers, there's 65 gigs of installed wind in 2042 for this future 3 versus 41 gigs. I mean, we're already at 28. So, is it a stretch to say we'll have 13 more gigs in the next 20 years? I think that's not a stretch. But I'm interested in the results of this. I think it'll be pretty good because it'll help give us a guideline on where to build transmission. Okay, I think I'm still doing pretty decent on time. Just moving right along. This gives you an indicator of conventional generator retirements. We have seen increase in retirements, but I did want to pause here just a little bit, and I do wish this was more of a discussion with you all. There's a challenge here because there are members that want to retire. I know that certain members have certain generators that everyone's business case is different. Everyone's rate and how they actually make their rates within their states are different. And I don't want to get into all that. But what I do want to highlight is we have this generation interconnection process, and we have this generator retirement process, and then we have this ITP that tries to predict the transmission grid and what it should look like. And so there is a little bit of a disconnect there, and we need to make sure that as businesses and members decide to retire certain resources, we ensure that we're not only building the right transmission, but we're replacing it appropriately. And that kind of gets back to my earlier discussion around how we design the resource capacity accreditation methodology for the region, and making sure that individual load responsible entities, for instance, NPPD, OPPD, or LES, have their greatest benefit in what their investment choices are when they invest in certain resource plans and choose to retire, if they choose to retire. And we need to make sure that all of those things blend together. They've traditionally worked very well in SPP, but given just the rapid nature of how we're accommodating various variable energy resources as well as the retirements, we just need to make sure this transition period that we're witnessing each year, we're constantly needing to study it and make sure that we're reliable. And we have seen increased retirements consistently. Okay, so moving right along, I wanted to talk about script a little bit. This is if you were familiar with SPP's HIT, we actually had in, I think it was 2017 and 2018, maybe off a year, it may have been 2018, 2019, holistic integrated transmission tariff team. And it was called the HIT. And what it was SPP kind of looking at all tariff business functions within SPP, working with members to identify high-profile policy changes that are necessary given all of the changes that are happening in our industry. Well, one thing, we did identify a few things in planning that needed to change, but not everything. And so what script is basically like a HIT, but for engineering business functions specifically. So it's kind of a long acronym. I can't take credit for it, but Strategic and Creative Reengineering of Integrated Planning Team. So just to give you kind of an update on what that looks like, we have a variety of studies and they're all designed for a specific purpose. We have stakeholder member funded studies such as the ITP, I mentioned that. That's a pretty exciting annual process. It's actually evolved over really the last 10, 15 years. And it comes up with a robust portfolio of transmission projects that are economic and reliably meet reliability needs. You also have other studies, high priority study, a balanced portfolio study, interregional projects. Those are a variety of studies with different cost allocation rules on the right. So you have highway, byway, highway only, highway, byway, subject to a safe harbor limit, and directly assigned. Some others we have is transmission service. So if, let's say NPPD wants to buy firm service from a solar farm, I don't know, in Kansas, and they want to have firm service from that resource, well, they'll put in a firm reservation and we'll determine at SPP what upgrades are necessary to ensure that firm service is deliverable from that solar farm to NPPD's load. And so if there is a determination there needs to be an upgrade, then it follows those cost allocation rules for transmission service. And then GI, we talked about GI, that is directly assigned based on the interconnection request itself. And we also have a separate process for sponsored upgrades. So any qualified member could come to SPP and with a particular project that they would like to upgrade, and they would have to pay for it. And what we do is just a no harm look and an optimization look to make sure that what they're building doesn't conflict with something that's already planned. So why did I talk about all those things? Well, the goal of planning is to be, it's all one grid. I mean, so if you look at these studies, there are all these different studies with all these different business reasons for them. We have, and I didn't even mention, AQ, where we have load increases and we have load requests for determining what the overall impacts for increase in load is. So they all have different timelines and they come up with different solutions. They also have different objective functions. So a GI, for instance, is a cost-effective objective function. So it's not seeking the most robust plan. It's only seeking the least cost to allow that generator to interconnect to the grid. That's fine in isolation. You look at it on paper and you say, okay, this is a solar farm that wants to interconnect. Should they be paying for a more robust transmission upgrade across the entire region? Maybe. And that's something that we need to talk about at Script, and we need to talk about further with the membership, is how best to look at this single grid that we're actually living and operating in and under, and how to look at cost allocation rules, timing of these business functions, timing of these studies, and try to do it more effective. And so that's really what it comes down to Script. You see some of these industry changes. Integrated marketplace, we had in 2014, consolidating 16 balancing authorities, it definitely changed the game. You have growth of wind, we've already talked about that. That's large amount of wind, solar's coming, it's changing the industry. excess energy. We already have excess energy, and it's only going to increase as we get the large amount of renewables that we anticipate. GI request volume, that's across the industry. That's not, it's MISO has a backlog. It's no one has really solved, it's not an SPP unique problem. No one has really solved this inrush of queue requests. Regional investment, that's definitely changing. Parallel studies, I mentioned that is continuing. So SPP, I've already mentioned the first one, lack of export capability. Now this is something that's an area of seams that has numerous items that we could potentially improve on, such that we can sell our excess energy to the Western Interconnect or to the East more effectively as a region, and it also benefits load in that case. Lack of consensus on planning assumptions, that's another thing. Depending on what member you ask, will we have that amount of solar 20 years from now? Will we have that amount of wind 10 years from now? That's a challenge because we need to make sure that we're doing the right thing. Ultimately, members fund these transmission investments, so we need to make sure that the studies that we have integrity and are trusted, and there's credibility to them. Lack of certainty about the future transmission investments. That's getting more and more challenging just by nature. We haven't even talked about distributed energy resources, behind the meter solar, EV charging, the variances of things that traditionally load has not had to mess with that much. You've usually had an incremental load increase of 1% or 3% or whatever it may be. And that part of the power balance equation is even getting more challenging. I mentioned the parallel studies and then concerns about inequitable cost allocation. So that's a pretty big challenge. So I'd like to wrap up with 2 more slides and then we can open it up to some questions. So what is SCRIPT? I don't want to read that long acronym again, but it's a group of stakeholders from the members, from the board, from the regional state committee. And it's a small group that's intended to work through these next 6 months, some of those challenges I mentioned from a planning perspective, with the goal to complete a package of policy recommendations in the October of this year round of meetings, MOPSI and board, that we meet at SPP. And the overall policies, what we're intending to do is try to consolidate some planning processes, improve certainty, reduce dependency on queue-driven analysis, improve decision quality. How can we study these futures a little bit better? How can we ensure that the transmission investments that we're studying have integrity and we can all support, yeah, this makes sense. This is the grid that we think we should be designing, and everyone can get behind it to some extent. There's always going to be some things that certain members, or SPP, depending on who you ask, might have an issue with this particular assumption or that particular assumption. But as a whole, and this is my personal view, if SCRIPT puts us in a better position to where we could come up with, let's say, a robust solution that maybe GI customers could help pay for, load could help pay for, and in the end, we're actually saving more money because we're looking at it more holistically as opposed to these one-off parallel processes, then it's a win-win for everybody. And so that's what we're hoping for. With that, these are so odd because it's just me talking to a camera. But I'll try to see if I can just engage with Courtney, and then she can give me the questions. But I didn't mention DERs or ESRs or hybrids. We have a lot of initiatives that we're working on at SPP. To try to best prepare for the future in this evolving grid that we have. Thank you.
Great. Thank you, Casey. We do have a couple of questions coming in, so we'll go ahead and start working through those. But first off, we've had several questions about the availability of these slides. So I just wanted to make sure folks are aware this presentation will be available in the next couple of days on the Nebraska Wind and Solar Conference website. So you'll be able to look at this again there in a couple of days. So Casey, first off, I think we've got some questions, so I'll kind of lump a couple together around SPP's backlog and processes compared to maybe some of the other ISOs in the US. So how does SPP backlog and the study process compare to MISO or other ISOs? And then are there things that other marketplaces are doing better with their queues that SPP could look to try?
Yeah. In general, we've looked at that, and I kind of mentioned it late in my presentation, but we have not found a magic bullet in other regions. And so there are different practices. Sometimes, I mentioned the cost of entry. There are we actually had a grid. I don't have a slide readily available, but we have a grid that compares what others do in their queue, and none of them are perfect. And so we are trying to borrow best practices from them. But I think what we need to do is think differently in what problem we're trying to actually solve, and really maybe blow it up a little bit. And I think that's going to be the challenge. Looking at the queue backlog and how to get through the backlog, I think is the easier part. The harder part is honoring the queue process and moving towards a new process. That's going to be a little bit of a challenge, just making sure that whatever policy changes we make, that we're being very fair to those participants that have been waiting for an answer for 4 years. So.
Great. And maybe one other similarly related question, kind of to how ERCOT does some things. What are the limitations of hiring outside firms to help improve the ability to process QI studies, similar to how ERCOT handles their interconnection studies?
We do that. We do have, we've actually done a couple of things, and that's again another slide I actually cut. It's so we've cut our models from 404 down 47%. So we're just over 200 models now. We increased with our three-stage process. Our first three-stage process was complete on time with the 2017 DICES, and we've added staff, I believe 8. Don't quote me on the total staff, but we have added SVP staff towards the GI process. We've actually pivoted some other existing staff to be able to help support some of the GI efforts, and we do have consultants as well. The issue is more of a process issue as opposed to a manpower issue, but the manpower issue is a component. I mean, if you have more subject matter experts working at this problem, we can certainly get it solved quicker. But again, this is our #1 corporate priority for 2021, as handed down from the officer team at SVP. And so to be clear, that's a big sign that we will have a plan put forward towards the membership to be able to get out of this backlog in fairly short order.
Okay, maybe a question around the mitigation plan. When do you estimate that a decision will be formalized on what route to take? And when can we expect to have an updated interconnection timeline that incorporates that backlog mitigation plan?
Well, I would say we're close. Again, we've been floating different options to the GI Users Forum, and then I just reviewed internal presentation yesterday. If depending on where we're at with members and how they react to the backlog mitigation plan, we could have something by the July MOPSI. But again, there's some work after that, because once we have that plan in place, we have to develop the language changes necessary to support that overall policy plan, and then file with FERC, because it will take some tariff changes. And again, going back to the previous discussion or question, the challenge to me, I think, is the transition period and making sure that the integrity of the existing process smoothens in the transition into the new process, such that no one's left out and FERC may have issue with it. So we are trying to kind of be in lockstep with FERC. I do want to mention that FERC is real keen on looking at their entire purview for the nation in solving this problem. And so we just want to make sure that we come up with a plan that transitions into the new process without leaving anybody behind. But from a timeline perspective, I would say by July, we should easily have an updated plan on where we're going. October, the latest, but really from an overall policy approach, I think July is reasonable.
Okay, great. I think you touched on this a little bit, but maybe a little bit more on, does the change in the federal administration affect your planning or your goals?
Yeah, yes and no. So we were already planning on having kind of an aggressive, this was mostly market monitoring driven and what they wanted to see in our 20-year assessment. There are other areas that we see as potential changes in planning. I'll mention it just because it's public. The Keystone pipeline permit hold. Well, there's a question there. What does that look like? We have to work with members on what that looks like and whether or not this load change in that area. And if load changes because of that pipeline, then we have to modify our planning studies to be able to address it. Now, that's a very targeted example, but I would say yes, the short answer is the federal administration change does change what we do. But there are some things that we were already underway that we were trying to look at to stretch the goals. Something I didn't mention and we're working on is a supply adequacy look on what it would take to run and operate the region solely with renewables. As far as I know, I've seen academic studies to that effect, but I've never seen a study specifically from an SPP perspective on what that might look like. That'll be an interesting area. That's something we're working on with the supply adequacy working group, and it is still academic, but it should be eye-opening as far as being more realistic in terms of what it might take to stretch that goal. And that does, obviously dovetail into Biden's plan for 2035.
Great. Let's see. I guess a question here on what impact will aggregators of distributed generation or storage have on the SPP marketplace? Will there be a queue for these players to enter the market?
Okay, so we do have, I'll try to make this quick. We've got 7 minutes left. I don't know how many questions. So there's a couple of things. We have FERC Order 2222. We're addressing that. To me, that's kind of like FERC Order 841 with energy storage or electric storage resources. That is more of a stretch in terms of allowing or removing barriers for market entry. There's a number of things that we're doing in the distributed energy resource perspective. One is you can see we have electrification in our growth for our projections. We also have EV, which I guess is not even called out, distributed generation of solar. We have 900 megawatts in one of our futures. We also have EV and specific targeting. It's kind of interesting, the science behind how we're projecting the EV growth. And so depending on where that question's going, we have a number of items that are in the works in trying to determine what variances we change in load so that we understand where the EV is, where the distributed energy resources are. From a market perspective, we are relaxing or changing the barriers for aggregators to allow them to participate. That's underway to meet the FERC Order 2222 issue. But we have things that are past that. We're working with the NERC, what's called the Spiderwig. It's kind of an interesting working group name. It's the System Planning Integration of DERS working group. And we're working with them to identify additional NERC standards to ensure that we have the data necessary to assess utility scale DERS as well as residential DERS in our footprint. There's probably a lot more to say there, but we've got hybrids that we're looking at. We've got logic that we need to look at in our adjusted production cost software because batteries can operate as a load or a gen, and trying to optimize that in our future studies, such as Future 1 and Future 2 in our ITP. Right now, we're kind of leveraging hydro pump storage logic, it works, but it's not necessarily the same as how a battery would operate in the market because batteries are much faster to charge and discharge incrementally within an hour. Great.
And I think have some similar questions, so I'm trying to lump them together here with the last few minutes left. Here's one. Can you elaborate on enhancements of transmission lines between MISO and SPP?
Yeah, so I've been involved in the last 3 coordinated system plans, and we have come very close. We have over 270 EHV and high voltage tie lines with MISO. So we have a pretty extensive scene with MISO, but we've yet to come up with one single interregional project. There's a number of reasons for that. The last year, we came up with one particular project, and in fact, it was close to Omaha's region, but it hasn't passed certain thresholds. It has to pass regional thresholds for SPP and MISO to agree on the cost allocation and sharing of that particular project. So where we're at today is we have a SPP MISO joint study, and I didn't really touch on this, but it's part of a little bit of script. This year, we were working on a joint study with MISO to look at the GIQ, and it's a lot of the wind and solar that's north of Omaha along the seam with MISO. And what we're attempting to do is try to optimize the interregional seam with MISO with transmission projects that may actually allocate costs. It's kind of a double whammy. You allocate costs to the GI customers as well as load in SPP and load in MISO, but you also help unclog the queue because you're assessing that collection or cluster of resources that are north of Omaha. So it's kind of a novel idea, but I'm hopeful that even if we don't get projects out of it, I think it'll be a nice lessons learned for the script effort and future policy changes.
Great. And it looks like we have 3 minutes. So I'm going to try to get 2 questions in.
Okay.
One on just, can you speak a little bit to the time spent by SCP looking to expand to the Western Interconnect versus kind of the time being spent on the generation interconnection backlog?
Yeah, so we have, it was kind of answered a little bit earlier with the additional resources and consulting contractors. We do assess that. The resources spent on the Western Energy Imbalance Market as well as the RC services are contract-based, so they are not part of the admin fee. But I do recognize where that question is coming from because if we're, from a priority perspective, what should we be doing? So there's a lot to unpack there because, it's a matter of long-term strategy as well as trying to meet the needs of our core administration and SPP's membership. And so there is a lot more there that I probably don't have time to go into, but we have increased effort and staff to GI.
Okay, great. And one more we'll try to fit in here. So you touched on retiring plants. Last month, there was an update to the FERC order regarding surplus interconnection service. Can we expect a second SPP queue for surplus interconnection?
I don't know if we can expect a second queue, but we are working on the policy changes necessary to facilitate that. I have not been entirely close to that, to be honest. But I can say that the principal engineer that's working on that policy change, we are trying to work on something that's more effective and efficient to be able to meet that need. Okay.
Very good. Well, I think that answers all of our questions. We've got a few seconds left, so I just want to take a minute to thank everyone. We had great attendance today, and thank you, Casey, for your time and expertise. It's always a lot to learn in a short time, so thank you so much.
Thank you. Appreciate it.